All right, welcome back, everyone. We are here finally to the derivatives. This is sort of one of the big lessons. This is one of those pages, this first page here, that you will want to refer back to often. So you may want to bookmark it somehow, and every time a problem comes up, maybe have that off to the side until you get some of these memorized. They're not hard to memorize, but we're going to start with some derivative rules. Remember, derivative is the prime notation is what we're using. So if we look at constant multiple rule, it's part A. It says d of dx, or d with respect to dx of k, which is constant, times a function of x, is the same as k times the derivative of that function. Now, we haven't gotten to how to find a derivative yet. That's the second half of today. We'll get to those here in just a few minutes. Sum or difference rule, if we're adding two functions, we can break them up into two separate, if we're adding or subtracting. And the big one, the huge one, the main one we are going to be using for most of the semester is here. This is called the power rule. There are a couple of others that we will be using, but this is one of the big ones. And it says if I'm given a function x to the n power, and I take its derivative with respect to x, the power comes down, so n comes down and becomes multiplied times x to the n minus 1 power. I'm going to show you just a couple of examples of that. So just a couple of examples of the power rule here. Oops, so we have y equals x squared, which means y prime is 2 times x to the first power. Y equals x to the 9th power. This means y equals 9 times x to the 8th power. And I'm hoping you start seeing a pattern on these after a while. X to the negative 7th power, y equals negative 7 times x to the negative 8th power. Right, because we're subtracting 1 each time on this here. Now, the derivative of a constant, which is our next one that we have here, d dx of k, is 0. So for example, the derivative with respect to x of 7 is 0. d over dx of pi raised to the e power, still a constant, it's going to be 0. All right, we're to our next main one. That's our exponential function. E is a very strange number. It's called a transcendental number, an irrational number. And it is above my ln button. If you go to my number 4 button, and just to the left, you see ln. And on my ln, you see in yellow, it says e to the x. So I'm going to hit second e to the x. And I'm going to raise e to the first power. And here's our weird number, 2.718, and so on. If I had time, I'd show you why this works, and there's graphs and things like that, but it doesn't quite work in a video. But if we were to graph 2 to the x and then graph 3 to the x, the graph of e to the x is somewhere in between those two. And the number is such a way that when you take the derivative with respect to x, you get the exact same function back. Any other base, you have the one below it, that's d dx of a to the x power is the natural log of a times a to the x. And the derivative of the natural log of x is just 1 over x. So these are some of the main ones that we need to keep an eye on. The ones that I didn't highlight are actually just variations of the power rule. But for now, these are our main ones. And the biggest one is the power rule at the top there. Yeah, those are the big ones. All right, so now we have some more complicated ones. What if we are multiplying two functions of x? How do we find its derivative? Well, we end up with the derivative with respect to x of f times g is going to be the derivative of f times just regular old g plus regular old f times the derivative of g. This is called the product rule. And this will be a little bit easier to do once we get to some examples. Quotient rule is even more complicated. It says if I take the derivative with respect to x of f divided by g, the numerator will be f prime, or the derivative of f with respect to x times regular g, minus regular f times the derivative of g over the function g squared. All right, and again, these won't be very useful until we do some examples. The big one here is the chain rule. We'll get to this, and right now it's just a bunch of gobbledygook. Basically, you take the big derivative, and then you go inside, take the derivative of that, then you go inside, take the derivative of that, and so on. Again, this will not make a lot of sense until we get to some specific examples. So let's start doing some derivatives. So make sure that you keep all of that somewhere where you can access it fairly simple. And here's homework 1. We have f of x equals x to the 10th power. Then the derivative, I already did something like this. This is going to be 10 times x to the 9th power. Remember, we subtract 1 with the exponent. G of x equals negative 3x to the 7th. 7 times negative 3 is negative 21. X to the 6th power. And h of x, in this case, is 1 over x to the 4th, or x to the negative 4th power. So its derivative is going to be negative 4x to the negative 5th power. Remember, negative 4 minus 1 gives me the negative 5. So when it's a positive exponent, it goes down. When it's a negative exponent, it gets bigger. And so here is our power rule derivatives. All right, for number 2 here, I'm going to rewrite f of x like this. This is 6 plus 8 to the negative 1 power, x to the negative 1 power, plus 3x to the negative 2 power. And I'm still going to use the product rule, power rule, pardon me. And remember, the derivative of a constant is 0. So derivative of 6 is 0. It's gone. This becomes negative 8x to the negative 2 power minus 6x to the negative 3 power. Now I'm going to rewrite that like this. Now you could probably leave it in the previous form to this, but I just really want to emphasize that they started with fractions, so I'm going to end with fractions. Now number 3, it's the derivative with respect to x of 4 times the natural log of x. Now I'm going to go ahead and pull that 4 out in front, since it has nothing to do with the function of x. If we look back on our list, the derivative of natural log of x, so this derivative is going to be 4 times 1 over x, which is 4 over x. All right, so I want you to take a look back at these real quick. We just used some of the basic rules, nothing too crazy yet. Number 4, we actually are going to have to use the product rule. Because we have two functions. We have a polynomial, 2x squared plus 3x minus 2, times an exponential function, e to the x. And the way the rule works, if we go back here to the product rule, derivative of the first function times the second plus the first function times the derivative of the second. So here we go. So the first function in this case is the 2x squared plus 3x minus 2. This just becomes 4x plus 3 times e to the x plus the original function, 2x squared plus 3x minus 2, times the derivative of e to the x, again, which is just e to the x. And we could distribute and combine and things like that, but I'm more interested in the first step, that we're getting all of that and we're using the product rule correctly. So you'll want to take a look at that again. Once again, the first term that you see, that 4x plus 3, comes from the derivative of 2x squared. The 2 comes down, times 2 gives the 4. 2 minus 1 is the 1. Derivative of 3x just becomes 3. The minus 2 becomes a 0, because derivative of a constant is 0. then e to the x, and then the regular original function, 2x squared plus 3x minus 2. And the derivative of e to the x is just e to the x. So there it is. Number 5 is quotient rule. To be honest with you, we tend to avoid the quotient rule at any cost. It's just very messy. So f prime of x is going to be the derivative of the numerator, negative 10x to the fourth, plus 28x to the third, plus 9x squared times the denominator, minus, and I'm going to have to rewrite down here, getting low on room, the original function, 2x, negative 2x to the fifth, plus 7x to the fourth, plus 3x to the third, times the derivative of the denominator, which is 4x to the third, all over x to the fourth squared. So it'd be x to the eighth. I don't have room to clean that up, but you can see we would need to distribute the x to the fourth up top, distribute the 4x cubed up top. Make sure when you do the subtract, you distribute the negative, combine your like terms and things like that. So again, that's more algebra than it is calculus. Number 6 and number 7 are the chain rule, meaning I have a function inside of a function inside of a function and so on. All right. So as we're looking at number 6, I see something raised to the negative third power, and then that something was 5x plus 8. So we have a function of x raised to the negative third power. So we're going to do quotient rule. I'm going to bring down that negative 3. So f prime of x is negative 3 times 5x plus 8 to the negative fourth power times the derivative of 5x plus 8, which is just 5. So I brought the 5 and the negative 3, multiplied them to get the negative 15. Now they specifically want f prime at 3, so this becomes negative 15 times 5 times 3 plus 8, negative fourth power. That's 15 plus 8. That is going to be 23 to the fourth power. And I don't know what 23 to the fourth power is. 23 raised to the fourth power. That's a big number. So this becomes negative 15 over 279,841. That is a hideous answer, but it's just some number is all we need to worry about. All right, so for number 7, I want to go off to the side just for a second and say if I have y equals root x, that's the same as x to the 1/2 power. If you remember our exponent rule in the previous video, when you have a square root and there's nothing in the index, meaning there's no value in here, right? There's not a 2, there's not a 3, there's not anything, then it's assumed to be a second root. So square root of x is x to the 1/2 power. And if I apply the product rule, or the power rule, then y prime becomes 1/2 x to the 1/2 minus 1 power, which is 1/2 x to the negative 1/2 power, or 1 over 2 root x. That's just sort of something to keep off to the side. Let me see, move that a little bit. Maybe not a great place to put that. Put that down here, just as an aside for now. All right. Keeping all that in mind, f prime, if I do this, x in my original example down here is the 5x squared plus 4x plus 2. We'll get to that. So this whole thing becomes 1 over 1 over 2 times the square root of 5x squared plus 4x plus 2 times the derivative of what's under the radical. That's going to be 10x plus 4. That is messy. And actually, we could factor a 2 out of that 10x plus 4 and reduce up the 2 down below, but we'll just leave it as is for now. The next part says we're going to evaluate that when x equals 3. So I'm going to have 10 times 3 plus 4 up top over 2 times the square root of 5 times 3 squared plus 4 times 3 plus 2. And we're going to use our order of operations to be real careful with that. That's going to be 34 up top. 2 times the square root of, let's see what we have here. Let's calculate that out. So 5 times 9 plus 12 plus 2, 59. There is, and that even reduces to 17 over root 59. And I suppose if I was a good teacher, I would rationalize the denominator, but that's not the point of this particular problem. This particular problem is getting from point A to point B. And once again, I want to emphasize that all of this is how I got, undo. Okay, so let's try that again. This is all directly related to how we got to here. So all the other sections weren't too bad, and now I'm suddenly throwing you into the deep end, where it's very, very mathematically heavy with lots of calculus all built into it. All right, let's keep going. So now we finally have some space to work with here. So we have f of x equals x plus 1 over x plus 2 raised to the 5th power. This is going to get really messy. All right, I'm going to start with the power rule. So f prime of x is going to be 5 times x plus 1 over x plus 2 raised to the 4th power. And now I'm going to do the quotient rule. Derivative of the numerator is 1 times x plus 2 minus the derivative of the denominator, or x plus 1 times derivative of the denominator, which is 1, all over x plus 2 squared. And maybe we can clean that up a little. Let's see, that's going to be times x minus x. That's going to be 2 minus 1 to give me a 1, it looks like. Over x plus 2 squared. And we can even clean that up a little bit more and say this is 5 times x plus 1 to the 4th power over x plus 2 to the 6th power. Because I remember inside the parentheses, the x plus 2 in the denominator is actually raised to the 4th power, and the 4 plus 2 gives me the 6. So you can see how we went from relatively simple to very algebra heavy. And again, if you ask any calculus student, they will immediately tell you that the hardest part of any calculus is all the algebra that's involved. So make sure you do your best to stay as caught up with the algebra as you can. All right, number 9. Looks like we have quotient rule again. All right, so derivative of e to the x is just e to the x. That's easy. Times the denominator. Minus derivative e to the x times the derivative of the denominator, which is just 5. And I suppose we can clean that up a little. And it looks like we can combine them for like terms, negative 2e to the x plus 5x e to the x over 3 plus 5x squared. I'll stop there. All right, so once again, we have chain rule for number 10. So f prime of x is going to give me 3 times 13. I'll multiply that out in just a moment. Negative 4x to the 7th plus 8x to the 3rd to the 12th power times the derivative of the inside. That's going to be negative 28x to the 6th plus 24x squared. And although we could probably clean that up, I'm just going to leave it as is. We can get the 39 out in front of the whole thing. Again, I'm more interested in that first step. Number 11, we have more chain rule. So this becomes f prime of x becomes 3e to the negative 4x to the 10th minus 10x to the 8th. Now I have to do the derivative of the exponent. That's part of the chain rule. It's going to give me negative 40x to the 9th minus 80x to the 7th. That is messy, but not hard. The biggest thing with these is you got to keep yourself organized. You have to really compartmentalize and break up each part as we're walking through this. All right, number 12. We have f of x equals 2x plus 7 minus 5x to the e power, or e to the x power, pardon me. We want to find the equation of the tangent line of the graph f of x at the point 0, 2 in slope-intercept form. No problem. Remember, the derivative is the slope formula. This is going to be 2 minus 5e to the x. And the point specifically is when x equals 0. They tell us that right here, that x equals 0. So the slope at x equals 0 is 2 minus 5, and e to the 0 is just 1, so this is negative 3. Sort of slope is negative 3. And very nicely, they've already given us the y-intercept. That's 2, right? When x equals 0, y equals 2. So our equation of the line is going to be negative 3x plus 2. Not too bad. All right, we are to the last page. The graph of f of x, 2x to the 3rd plus 9x squared minus 168x plus 23 has 2 horizontal tangents. All right, what that means is a horizontal tangent, just as a quick reminder, horizontal lines have the slope m equals 0. And remember, m is the derivative. So if I take the derivative, f prime of x, I get 6x squared plus 18x minus 168. And I want to know where that equals 0. Okay. Let's start out. Let's see. 168 divided by 6. Come on. Yes. So I'm going to divide through by 6 just to keep it easier. You don't have to do this. It's just, again, to make it easier. So this gives me x squared plus 3x minus 28. When I divide through by 6, so I'm getting these two values. For when the horizontal slope, which is 0. So I find the slope function, take the derivative, set it equal to 0. We're going to do that quite a bit, actually, during the course of the semester. What is the negative value of x where the horizontal tangent, oh, the negative, I see. So it's -7 and a +4. So there are our two answers. All right, suppose the product's revenue function is given by R of Q equals -8Q squared plus 900Q. Find an expression for the marginal revenue function. Remember, marginal means that we're taking the derivative, and record your result in the box below. Okay, so we are going to find the derivative. So this is going to be R prime of Q, meaning the derivative of R with respect to Q. This is going to be negative 16Q plus 900. And that is it. That's our whole answer. Does it have us evaluate? It does not have us evaluate it anywhere. Yep, that's it. Oh, so there is a second part here. Suppose the product revenue function is given. Find the numeric value of the marginal revenue at 16. Okay, so we're gonna have to do. Oh, that's for number 15. I see this is a separate problem. I was confused. Okay, so let's find the marginal revenue of we'll say a Q, which is R prime of Q. So this is negative 10Q plus 1,000. And so if we are MR at 60, negative 10 times 60 plus 1,000, that's going to be negative 600 plus 1,000, or 400. Meaning this is going to be $400 per unit. All right. Last problem for this video. Given that f of x equals x to the 10th times h of x, and they give us some specific values. Okay, so let's find f prime of x using the product rule. That's going to be 10x to the 9th times h of x plus x to the 10th times h prime of x. And they want to specifically know this here. This is going to give me 10 negative 1 to the 9th power times h of negative 1. That should be 10, not 16. Yes. And so that's going to be negative 1 to the 10th power h prime of negative 1. And let's see, this is going to be negative 10. 10. So negative 1 to the 9th power is negative 1 times 10 is the negative 10. H of x of negative 1 is 4. Negative 1 to the 10th power is positive 1. And h prime at negative 1 is 7. So I'm getting, let's see, negative 40 plus 7 is negative 33 is what I got. All right. Well, welcome to the world of derivatives. That will be something we will use for the rest of the semester. Thank you.